let's have a quick chat about SCORM latency. This is something that often gets overlooked, but you do run into it. I've seen it on a few platforms, and when it happens, it weakens the user experience. Latency happens. I mean, it's a combination of your system traveling through the internet to the LMS and everything in between. So when you're playing a multiplayer game, or you happen to be trying to use a voice or video client with a family member or friend, you'll sometimes notice things go horribly wrong. And that's a combination of everything that the information's passing through that can become latent. And it can also be related to lack of bandwidth. Somebody else on your network, your family, your home, whatever happens to be going on, is limiting your ability to get what you need to get done. Now, SCORM's not much different. I mean, we've got this student attempt that it has to be prepared before your content launches, and that's so the content can gain access to everything that it either did before, or it's a new attempt that means it's going to go ahead and begin to set up everything for this session. This has to be available at runtime, so this means the LMS is preparing it, and then it's launching the content. If you're new to SCORM, you might have been thinking like, well, I thought I'd have access to all this information immediately. And the answer is no. Everything has to travel through a controller. That controller is managing, much like a police officer in traffic, it's managing who can go, who can't, and what data can go in and what can't. So that's how that works. There are 3 modes that an LMS prepares this student attempt and then manages it. The first one's non-cached. So every single request is taking this round trip from your laptop or your mobile device or your desktop to the LMS, and then it has to come back. Now, if you're latent, let's say 100 milliseconds to 250 milliseconds, or the server's just under a heavy load of students taking courses, especially with video, the pipe starts to get much smaller than it was. And as you've seen when you're streaming movies at home or you're doing some other, like I said, video conference, and things start to get laggy, pixelated, or blip out altogether, you begin to have a much weaker experience. Now, I've personally seen testing content, the hourglass start, and I can't click anything, I can't scroll. And that's because SCORM is making the upwards of a dozen calls or more to maybe status some information. And that, as I stated, weakens the user experience. So what can you do about it? Well, there's 2 other approaches, but I will say there is a pro to a non-cached, and that's that as data is set, if the power was to go out or another student was to unplug your Ethernet cable from your device, or if you were to lose Wi-Fi connection, hopefully and theoretically, all of your data is still there, so when you come back, you can take off right where you left off. In a cached implementation, your student attempt's available on your local device, on your browser per se. So the communication between the content and the browser is immediate. It's almost zero lag. There's going to be some lag built in because it's processing and making sure all the I's are dotted and all the T's are crossed. But for the most part, when you call commit within the content, which is the act of a student hitting save or something that's automatically occurring, like an autosave every couple minutes or 10 minutes, that data is then making that round trip, but it's only one request, it's not 20. And that's why you don't see this huge amount of lag. And lastly, there's a cached hybrid. This is just like cached, except it's only submitting what's changed on commit. So if I only changed my status type, set my session time, and then committed, it's only going to send those 3 data values as opposed to the whole student attempt. Now, I've been asked, how big is the student attempt? Well, in regards to browsers, commonly what happens is this data gets compressed between the 2 points, much like zipping up a file. So when I quote a raw number, understand that that's probably getting compressed. But I would say an average student attempt could be 9K or kilobytes up to, say, 14 to 20 kilobytes, depending on how much raw data is there. And that's all the information that's stored in your suspend data, which is commonly a string. It could be considered almost like a text, essentially, that could have delimiters, so pipes, commas, hashes, whatever they happen to be, to try to convey information in a structured way. They could even be XML or JSON, but JSON's commonly used a little bit more. If you've ever seen a CSV file, that's a pretty good basis for what suspend data might look like. Now, I've got a test harness here that I've had a number of years, and it's dreadfully due for an overhaul, but there was some content I was testing earlier, and I'm going to go ahead and launch it. Now, if I was considering this platform for my content, I'd first want to see, hey, can I take a beta, upload some of my content or preview some of theirs, and then see how it plays. There's a bookmarklet that's been built out for a while called SCOverseer, which oversees the communication going on between the content and the server. Now, keep in mind, you do have to hit refresh, so if you've interacted with the SCO and you want to see if anything's been changed here, you need to relaunch it. But I've added this RTE performance that gives you an idea of how much lag is occurring between your content and the LMS. And this one's really low, and that's what you want to see. And this I know because I've implemented it. It is a non-cached this is a cached implementation. A non-cached you could see the 250 millisecond, you could see 100 milliseconds, and that's where you're going to start to see the stackable lag. So I hope that all makes sense. I'm going to leave it there, and hopefully this didn't take too much time. But if anybody's got any questions, concerns, or otherwise, please let me know.